The Maclaurin series is a special case of the Taylor series when the series has its center of convergence at c equals 0. So when we construct these series, we're just going to evaluate the derivatives all at 0. So we can construct a series to represent functions by differentiation and using theorem 1 to calculate the coefficients of an. So let's see what this looks like. So we're going to construct a series for sine x at c equals 0. So to do this, what we're going to do is we're going to first of all generate the derivatives. So I'm going to start with n equals 0. We end up with sine x. We're going to evaluate it at 0. So our first term is going to be 0 for this one. We differentiate sine to get cos x. Cosine at 0 is going to be 1. So our coefficient is going to be 1 over 1 factorial. Our next derivative is going to be negative sine x. It's going to be 0. We're going to get negative cosine x. Evaluated at 0 is going to be equal to 1. Sorry, negative 1. So we get negative 1 over 3 factorial as an an coefficient. We get sine x. Evaluate 0 as 0. And then we get cosine x. Evaluated 0 is equal to 1. So our coefficient is going to be 1 over 5 factorial. Okay, so we've generated all our derivatives. We've calculated our an terms. So then we can write our Maclaurin series for this. So we're going to write it like this. Our Taylor polynomial, and we're going to use a fifth degree polynomial. So t of x is going to be equal to 0 plus 1 x to the power 1 plus 0 plus, that's going to be minus in this case, minus 1 over 3 factorial, which is 1 over 6. The polynomial part, the series, the power series part of that going to be x to the power 3 plus 0 plus 1 over 5 factorial works out to be 1 over 120, and then the power series part of that going to be x to the power 5. So simplifying this, I'm going to get our fifth degree Taylor polynomial is going to be x minus x cubed over 6 plus x to the power 5 over 120. So this represents our fifth degree Taylor polynomial. So we can use this Taylor polynomial then to estimate values of sine. And we're going to use this Taylor polynomial to estimate the value of sine of 0.3. So when I plug this into the Taylor polynomial, this is going to be approximately, I'm going to maybe write it like this. So sine of 0.3 is going to be estimated by this Taylor polynomial at 0.3. So when I plug this in, I'm going to get 0.3 minus 0.3 cubed all over 6 plus 0.3 to the power 5 all over 120. And then working that out on the calculator, it works out to be 0.2955025. Okay, so that represents our estimate for sine of 0.3 using that Taylor polynomial. And if we take a look at the actual calculator value, the calculator value, notice that up to even the 6th decimal place, there is a match. Okay, so even up to this decimal place here, there's a match. So with the fifth degree polynomial, we already have a high degree of accuracy using our Taylor polynomial.